Hi, I'm Pat Kelly. In this problem, you can see that they give us 4 points in 3 space, and they ask us to show that those are the vertices of a parallelogram, but then also to show or find the area of that parallelogram. Okay, so let's get to it. Now, you know from geometry, you remember this, the idea of a parallelogram is that it's a quadrilateral, but specifically the pairs of opposite sides are parallel. You got to be thinking that way in terms of showing work in this type of problem, because what we're going to do is find those 4 sides. A, B will be one of them, but we find them as vectors. Okay, we'll find all 4 of them. I've got to start it at least for what we're going to look at, but my point is that we're going to look at them as vectors, and then if we can see that the vectors are parallel to each other, the ones that correspond to the opposite sides, then you've met your definition of parallelogram, and that's what they want us to show. Okay, so a little bit of vector work to begin is that you do want to be able to express this vector AB component-wise. Right? And the way that I would do that here then is grab your terminal point, so my second letter there, my B, and what I do is just subtract component-wise. So 3, I'm going to subtract with the component, the corresponding component from the A vector. Okay, so 3 minus 2 is 1, and that'll be in the I direction. And now my J direction is going to be, again, corresponding. Start with your terminal point, though, the 1 for my middle coordinate. Subtract a minus 1 looks like a plus then 2J. And then my third will be 2 subtract 4, looks like a minus 2K. All right? So we've got the ball rolling, but this is what I meant by seeing the sides of this quadrilateral as vectors. We've got one of them. Let's find the other 3. So I'm going to find AD doing the same work. I'll start with my terminal point of D and do -1, subtract 2, looks like a minus 3I. 3, subtract a -1, so it'll be plus 1, that looks like plus 4J. And then 8, subtract the 4, looks like plus 4K. All right, then I'm going to move to CB as a vector. My terminal point here of B, so I'm going to do 3, take away 0 is 3I. 1, subtract 5 will be -4J. And then 2, subtract 6, looks like that goes down to a minus 4K. One more, that'll be my vector CD. Do the same type of work. My terminal point here is D, so -1, subtracting 0. -1 subtract 0, -I. Okay. Next I would be looking at the 3, subtract the 5 is a -2J. And then 8, subtracting the 6, looks like a plus 2K. All right, so you have your 4 different sides represented as vectors. What good does that do you? Remember, we're looking to see if opposite sides are parallel. Vectors being parallel to each other means that they're multiples of each other. So take a look at, in this case, CB, 3, -4, and -4 for the components, and compare that to AD, -3, +4, +4. These two guys are just multiples of -1 of each other. Okay? Now I'm going to switch and look down at CD and up here at AB. And again, they're multiples of each other, and actually negatives again. So -1, +1, +2, -2. So multiples of each other, which means that the sides are parallel. And I should say opposite will look a little bit better, more exact. Opposite sides are parallel, which means we've shown that this is a parallelogram, part A. Part B was to find the area of that parallelogram. And this is where we get to use a cross product, because one of our cool uses of the cross product is that if you grab 2 adjacent sides of a parallelogram, find the cross product of those, and then magnitude of that, you got your area. So I'm going to grab these two guys because they are adjacent to each other. They share point A, and also because they're easiest for me to see right now. As I throw them into that determinant form to find cross product, top row is I, J, K. Second row will be 1, 2, negative 2. Third row will be minus 3, 4, 4. Just grabbing components. Okay, and then use your cofactor expansion approach to evaluate this. My little mini submatrix will be 2, minus 2, 4, 4 times the I vector. Part of your cofactor expansion then, you always have that minus sign in front of your next component, the J component, and the submatrix here will be 1, minus 2, minus 3, 4, J vector, plus, and then my next submatrix will be 1, 2, minus 3, 4, times our K vector. All right, so crisscrosses here, we're getting 8 minus a minus 8 times the I vector. Subtract, crisscross here looks like 4 minus 6 is the J vector, plus another crisscross of 4 minus a minus 6, so plus 6, K vector. And I'll go down to clean that up just a little bit. The arithmetic, 16 I minus, this is going to be a minus 2, right? So plus 2 J vector, and then plus 10 K vector. Looking good. And then what we actually want is the, in terms of the area, they asked us for area. We need the magnitude of that. So the area will equal the magnitude of what we just found was AB as a vector crossed with AD as a vector, and we need the magnitude of that, which will equal, you know, your magnitude formula is we're doing the square root of 16 squared plus 2 squared plus 10 squared, all under the radical. And this will equal, let's see, I could grab a calculator, but this is 256 plus another 4 would be 260 plus 100 looks like the square root of 360. And that's not a perfect square, but I might simplify that by pulling out the 6, and I would the 36, and I would have a 6 outside of the radical times the 10 that would still be inside the radical, or a decimal equivalent if you are jumping to a calculator. I like this answer as long as I tack on square units. Then I like this answer. And that'd be it. That's my answer. Try some on your own, okay?